All right, so we're going to prove a new rule today. I know recently I've been kind of giving you the rules, and if I flip back one page, that's what we're going to learn in a minute. But before we do that, we're going to prove it. So we're on page 23. We're going to prove the chord product theorem. And then after we prove it, I'll show you kind of a nice way to remember it. So looking at this picture, we can see we have some chords drawn into a circle. And I'm going to kind of give you the end result. We see the end result that we want is to prove that AE, right here, times EB equals CE times ED. So I'm kind of giving you the answer, and we want to figure out how we got to that answer. So if we think back to earlier in the year, this is a Unit 7 topic, similarity. So if we remember our similarity proofs, what we were able to show were that two triangles were similar because of angle-angle, so that was kind of our first step. Once we proved that triangles were similar, we knew that the sides were proportional, so we could set up a proportion like this. And then the third thing we did was we solved, so we ended up with basically this form, where we had two segments times each other equals the two other segments multiplied by each other. And that was all built off knowing that triangles were similar. So if we had these similar triangles, we could then go through this step-by-step process to end up with a nice equation that we could solve. And that's exactly what we're doing here. We're trying to prove that some pair of triangles are similar in order to use this step-by-step process. So this was actually a 6-point question in last year's Regents, was doing this exact thing. So I'm going to walk you through it with step-by-step, and we're going to do a paragraph proof. So the first thing, hopefully, we realize that we don't have triangles yet. We have these chords within our circle, but we need triangles in order to use this rule. So what I'm going to do first is I'm going to take a little line here. And we talked a little bit about this. I'm going to draw in a pair of auxiliary lines. So actually make those a little bit darker. I'm going to draw in a pair of auxiliary lines from B to D and from C to A. And we didn't break any rules. We just kind of drew in a couple new chords there. And now we have some good triangles. Now we have triangle BED to work with, and then triangle CEA to work with. So now remember, to prove triangles are similar, we need angle-angle. So I guess the first thing I see is that we have a bow tie proof. We have one pair of angles right there. So I'm going to start off this proof by saying angle CEA is congruent to angle BED because vertical angles are congruent. That's one of our two angles. We only need two. We have one already. So what we've talked about this year is going through the process of elimination. We only have two other pairs of angles to work with. That's our only option. So let's take a look. Let's look at angle D. Yeah, let's look down here. So angle D. I don't know if we have parallel lines. I don't think we can prove parallel lines cut by a transversal, right? These kind of look parallel. But I don't know if that's something we can prove for a fact. But what we do have, what we can use, are our circle rules, right? The quiz we just took, we know angle D, the vertex is right on the circle. So angle D is an inscribed angle, and it opens up right there onto arc CB. And if you look carefully, if we look over here at angle A is also an inscribed angle. It's also right on the circle. So if I trace the lines of angle A, look what happens. Angle A opens up onto the same arc. They both open up onto arc CB. So if I just make up a number, I don't know, let's call arc CB 50, totally making up that value. That means angle D is 25, it also means angle A is 25 because they're half of the arc. So what that tells me, that whole process, once we found that these two vertices, that D and A, both open up onto the same arc, that means they're congruent. So that's our second angle right here. And we can kind of say this in our own words. So let's see, let's think about this. I can say angle A is congruent to angle D because, and this is where we have to just put this into our own words. We don't have a special rule for this. Angle A is congruent to angle D because if two inscribed angles intercept the same arc, then the angles must be congruent. So kind of a weird rule, one we've looked at a little bit algebraically but never in a proof. So now I'm going to go a little quick here. We're done. We have our two pairs of angles. So now we can prove for a fact that triangle CEA is similar. So we know our symbol for similarity. Triangle CEA similar to triangle BED because of angle-angle similarity. All right, so if you need to pause and slow it down, please do. I'm going to go a little quicker here. Like I said, when the triangles are similar, now we know that the sides are proportional. So if you look really carefully what happened here, here's triangle CEA. So we have the vertical angle, we have angle A. And here's triangle BED. So BED, and we have the vertical angle, and we have angle D. What we're used to seeing on a lot of these is this being a rotation to map the triangles onto each other, right? To have to match up A with B because of the rotation. But look carefully here. All this is just a reflection to get these triangles to map onto each other. It's a reflection followed by, probably some kind of dilation with some unknown scale factor. So there you go. There's a nice little reflection. So you can see angle A and angle D match up. So side AE and side DE, those are your corresponding sides. So a little nice review of similarity here. So for example, CE and BE, those are the corresponding sides. EA and ED, those are the corresponding sides. So what I can say next is that CE is to BE, so this CE is to BE as AE is to DE. So CE is to BE as AE is to DE. So I'm just lining up those corresponding sides because we know this is a rule from a long time ago. Corresponding sides of similar triangles are proportional. All right, so we found that the triangles were similar. We then were able to line up their corresponding sides. And now we can do that cross product rule. We can multiply those two together. So now the last thing, and this is where our rule comes from, I can say that CE times DE equals BE times AE because of the cross product rule. All right, so you may not remember all those steps. We haven't done one of these proofs in a while, but what you should hopefully remember are your similar triangle rules. You need to find which sides correspond. So CE corresponds to BE, EA corresponds to ED, and that's how we set up our proportion right here. And what that tells me, if I look back at the picture, the rule that you're going to need to do on your video today, on your homework check, we know that CE times DE equals AE times BE. So what we're going to do is kind of multiply right along each chord to find what the missing values would be. And I'll tell you a nice way to remember that next time. But if I go back to the previous page, I'm just going to do one really quick example. Don't worry about writing that definition down. If you look at number 1, using the rule we just learned, you don't have to do the whole proof, but I know that basically 9 times 5, so using that proof we just did, 9 times 5 has to equal 3 times x, because of that similar triangle proof I just showed you. All right, so the math is pretty easy, but I did want to show you the rule behind it. All right, your homework check has to do with these. Good luck. See you next time.